guys, in this video I'll be going over the rational expressions notes. So to get started, we have a divide by inspection warm-up. Remember, for dividing by inspection, the first thing that we want to do is factor the numerator and denominator of our fraction. So for this first one here, if I set up my big X and I come up with my factors, I'm going to go with -5 and 4. So we get x plus 4 times x minus 5. And then for the denominator, setting up big X, I have 25 over -10. And my two factors would be -5 and -5. So x minus 5 times x minus 5. From here, the divide by inspection, that is where we just cancel out any terms that the numerator and denominator have in common. So these two would cancel out. Even though there's two x minus 5s in the bottom, I can only cancel them out in pairs, okay? So it only cancels out one. And I'm left with my final answer, which is the x plus 4 in the numerator over x minus 5 in the denominator. For the next one, I'm going to factor. The top has a GCF of 6x. So I factor that out, and I'm left with x plus 8. And in the denominator, I have 9x cubed minus 15x squared. From that, I can factor out a 3x squared. And I'll be left with 3x minus 5. Now here, the x plus 8 and the 3x minus 5 factors, they're not the same, so they don't cancel. But if you look out front here, the 6x over 3x squared, these ones actually can simplify. So it's not like a canceling factor, but I can simplify GCFs when they're written out there like that. So we're going to treat each of these like their own separate fraction. So look at the 6 over 3. Does 6 over 3 reduce? It does, to 2 over 1. And then the x over x squared. Now I'm going to look at the x's. Does this reduce? Well, if I have an x divided by x times x, that would become 1 over x. So put that together, and I have 2 times 1 in the numerator, 1 times x in the denominator, and then those factors, x plus 8 times 3x, and then 3x minus 5. Again, this is just a quick review from what we've done before, but if you're not sure about how to simplify these two or anything that I did here, make sure that you're getting some help before moving on. All right, so what values for x would make these fractions undefined? What does it mean for a fraction to be undefined? So a little reminder that an undefined fraction, that is a fraction that has 0 in the denominator. That is not allowed. We cannot divide by 0, and so that would make our fractions undefined. So looking back at this first one here, the x plus 4 over x minus 5, what value would make this fraction undefined? Essentially, what value for x would make the denominator x minus 5 equal to 0? And that would be x equals 5. In my second example here, I have two x's. I've got that x out front and then the 3x minus 5 factor. If either one of these is 0, the denominator will be 0 because anything times 0 is 0. So I have two values. So set x equal to 0 and set 3x minus 5 equal to 0. I've got to solve this one. So I get 3x equals 5, divide by 3, and x equals 5 thirds. Now, are those solutions? Do I want x to equal these values? No, I do not. So really, the way that we're going to write this is x cannot equal 5, and x cannot equal 0, and x cannot equal 5 thirds. Because those x values would make our fractions undefined. These values are called excluded values. That's why we say it cannot equal them. They are excluded from the values x can be. All right, one more quick warm-up. just throwing it back to multiplying and dividing fractions, just normal fractions. So how would I multiply 2 over 9 times 3 over 7? If you're not sure, use your calculator. Have your calculator multiply these for you, and then look at what fraction you get as your answer. Maybe that could help you make some connections here. But I'll tell you that for multiplying fractions, we always multiply straight across, the numerator times the numerator and denominator times the denominator. So 2 times 3 is 6, and then 9 times 7 is 63. All right, can I simplify this fraction? Yes, I can. 6 and 63 are both divisible by 3. So I get 2 over 21. How about when we divide fractions? How is that different than multiplying? We cannot divide a fraction straight across. Instead, maybe you remember this from elementary school or whenever you learned it, we do keep, change, flip. In keep, change, flip, we keep the first fraction the same. We change the sign, so from division to multiplication. And we flip the second fraction. The numerator becomes the denominator becomes the numerator. Then we proceed like we just did in the last problem, where we multiply the fractions straight across. So 5 times 16 is 80. Over 12 times 15 is 180. Both of these are divisible by, 20? Maybe a little bit higher than 20. 20 will work. And when I divide them by 20, I get 4 over 9. So now we are going to apply this to rational functions. Well, what is a rational function? Really, we've actually already seen them. Rational functions are just like what we saw when we did divide by inspection. Essentially, they are fractions that have polynomials in both the numerator and the denominator. When we multiply these rational functions, we multiply them just like we multiply fractions. So we are going to go through the steps here. Now, it's written out there on the side for you, and you notice step number 1 says A cannot equal 0 and B cannot equal 0. That would be 0 in the denominator. So step 1 is going to be to find those excluded values. Before you even start simplifying, find your excluded values, because even if they cancel, they're still considered an excluded value. For this example right here, because there's no actual factors, we're just setting A equal to 0 and B equal to 0. There's nothing to solve. So A cannot be 0 and B cannot be 0. Step 2 is going to be to go ahead and multiply. So I'll start by multiplying the numerator. 18 times 5 is 90. And then A cubed and B to the 4th, they can't really combine, so we're just going to write them. And then in the denominator, 20 times 6 is 120. Again, A to the 5th, B squared. Now I'm going to simplify. So 90, the 90 over 120, that's where I'm going to start first, is with the numbers. We're going to take this piece by piece. So starting first with the numbers, 90 over 120, 90 and 120 are both divisible by 30. So if I divide each by 30, I'm left with 3 over 4. Now I'm going to move on to the A's. So I have A cubed over A to the 5th. When we divide variables, remember we said we can subtract the exponents. So here I could subtract the 3 and the 5. When you're doing this, the easiest method is to always subtract the largest from the smallest. So 5 minus 3 would get us 2. But then remember that your variable is going to land wherever the larger exponent was. So because a to the 5th is in the denominator, a squared, the simplified variable, is going to still be in the denominator. Where now let's see the same thing with the b's. I have b to the 4th over b squared. B to the 4th is larger and it's in the numerator. So I know that b, whatever it simplifies to, will also go in the numerator. Well, 4 minus 2 is 2, and so we get b squared. All right, so we've done part 3, which is to cancel the common factors. Here is our simplified answer. All right, let's go over this next example here. In this one, we're given it already in factored form. So right away, I can find those excluded values by setting all of the factors in the denominator equal to 0 and solving for x. The next thing I'm going to do is just write it together as one fraction. So really, when it's in factored form, you don't have to actually multiply everything out. I can just make this one big fat fraction and start trying to simplify. Looking for factor pairs that are in common in the numerator and denominator, I see the x plus 2's, so those two cancel. I also see the x minus 7's, those two cancel. And nothing else cancels, so now I'm going to rewrite my final simplified form. I have the x plus 3, and then I have x. I'm going to write it out front just because that's where I like it, but you can write it in the back. And then the x minus 2. All right, there is our simplified factored form. You could multiply it out, but we won't really ask that of you. It's okay to leave it in this form right here. All right, so in these next two examples, you're going to have to first start by factoring, and then you're going to have to find the domain restrictions or the excluded values and cancel out those like terms. So let's get started. Starting with the first piece up here, the numerator of the first fraction, that one has a GCF of x. So I bring out the x and I'm left with x minus 4. The denominator, that's x squared minus 16. Remember, that's a difference of two squares, a dots problem. So that one factors to x plus 4 times x minus 4. The next one over here, I'm going to factor out a GCF of 5y squared. And I'm left with 3x plus 1. And in the denominator, the 3x squared plus x, I can factor out a GCF of x. And I'm left with 3x plus 1. All right. Now, before I go ahead to simplify, I'm going to look for those domain restrictions or excluded values. Both of those, I'm looking for the same thing. So we've got 4 factors in the denominator, the x plus 4. We get x equals negative 4. We've got x minus 4. We have just the x, and then 3x plus 1. So we have 1, 2, 3, 4, but remember x cannot equal these values. All right, next thing we need to do is to simplify. I see 3x plus 1s can cancel, the x minus 4 can cancel, and that x out front can cancel. So I'm left with 5y squared in the numerator over x plus 4 in the denominator. For this next one, I'm going to have to do big X for all of them. So negative 33 and 8, that would be 11 and negative 3. So x plus 11 over x minus 3. I'm going through the factoring kind of quickly because at this point it is expected that you know how to do this. But if you're struggling with factoring still, Remember to go to tutoring and ask for help. The factoring really never goes away in this class, so you want to make sure that you're getting the help you need to be successful. All right, and I have one last piece to factor. 11 and -1. All right. The next thing I need to do is find those domain restrictions or excluded values. Again, coming from the denominator, the x plus 2. I know that tells me that x cannot equal -2. The x minus 3, that tells me x cannot equal +3. Remember why? It's because that would make the denominator 0. 3 minus 3 is 0, right? The x plus 11, I cannot plug in a -11. And then the x minus 1, I cannot plug in a +1. So here's my excluded values. That's the first part of my answer. The second part is my simplified fraction. So I'm going to start canceling them out. I see 2 x plus 11s. I see 2 x minus 3s. When I say 2, remember 1 is in the numerator and 1's in the denominator, just like for the x plus 2's. And I'm left with x plus 7 over x minus 1. So there's our final answer.